All right. Welcome, everybody, to the Unity Basics workshop. My name is Josh Whidbey. I'm a fourth year computer science major. I've been using Unity for about as long as I can remember. So, goal here is to teach everyone the foundations or give a nice introductory to Unity. So, hopefully, if you haven't used Unity before, you can learn a thing or two. And even if you already have some experience, you'll probably pick something up here and there. All right, so let's get started. Oops. All right. So first off, I should preface I'm a student fellow with the Digital Humanities Consortium here on campus. The Digital Humanities Consortium is a collaborative space where students connect technology, creativity, and humanities. But basically, what that means in layman's terms is we host workshops teaching students how to do or how to interact or create different digital humanities, which is like video editing, hosting podcasts, and like in this case, for example, learning how to make games. So if anyone's interested in checking out the DHC or looking at any other workshops we have, I do have a little QR code right here. And if you want to check that out, you can scan it right there. And I'll keep going. All right, so the agenda for today, we're going to start off with a little introduction to Unity. And then we're going to walk through installing Unity, which if you're attending, I think you should already have it installed. But if you're watching this over video, it should also be useful. We'll do a little walkthrough there. And then we'll talk through navigating the editor and then a little sandbox walkthrough that I created for everyone to get a little hands-on feeling with Unity. All right. First off, let's start with an introduction. Unity is a free cross-platform game engine developed by Unity Technologies. It can be used for building 2D games, 3D games, VR, AR games, etc., and it uses C# for scripting. So it's a game engine the same way Godot is a game engine or Unreal Engine is a game engine. Unity, I would say, is probably one of the most popular game engines out of the three, although Godot is really on its tail coming up because Unity has had a couple scandals here and there. Unity uses C#, Godot uses GDScript, and Unreal Engine uses C++ and Blueprints. I do like Unity the most because it's what I grew up learning with. It's what I grew up making games with. But also, if you are a computer science major here on campus, lots of the projects that you start off with are most likely in Java, the programming language, which is very, very similar to C#. If you understand Java, you basically understand C#. So making that transfer over should be pretty smooth. All right, here's some games made in Unity. We have Among Us, City Skylines, Hollow Knight, Lethal Company, and Genshin Impact. All of these, I would say, are pretty big hitter games. The engine is used by AAA developers and indie developers alike. I mean, Team Cherry is a pretty popular indie developer. Zeekers, who made Lethal Company, was literally a one-man team who made the entire game. Hoyoverse, I'm pretty sure, is a AAA developing team. So it has been used by a whole bunch of different people, and it has proven itself as like a real game engine. Like, this isn't a game engine that only niche people use. This game engine has been used to make games that have shaped the gaming landscape. So you are among giants when you use this engine. So let's get started on installing Unity. So if you do not have Unity already installed, you can go to their website, unity.com/download, and then there will be a little button right here. It'll say download for Windows or Mac or Linux, and you can download it there. So this isn't going to install Unity the engine. What this installs is Unity Hub, which you can see on the bottom right here. So Unity Hub is kind of like a project manager. Here's where you can see all of the engines that you have installed, and you can also see all of the projects that you have started. So in the Unity Hub, you can create projects, add existing projects from your hard drive, or install new engine versions. So if I open up my Unity Hub right now, You can see right here, I have projects that I've already created. So I have a workshop project and then another test project. I can add projects up here from this add button, and then add from disk and add from repository. I can create new projects right here, which I'll go a bit more in depth on what everything is going on here in a second. And to install the engine, you actually need to go to the installs spot right here, click on installs, and then over here, you'll have all of the Unity engine versions that you have installed. So if this is empty, you can go into the top right up here where it says install editor, and then you can see all the official releases that Unity has. So these are the engines that Unity recommends. It's their latest version, the most stable versions that they've had through history, and the most popular Unity editor versions. If you're also interested, they have pre-releases, so you can use the alphas and the betas of newer Unity versions, which if you're really interested in checking out the differences or the new features that these engines have, you could install them, but I wouldn't recommend starting a long, year-long project or anything of that sort on one of these pre-releases, because they can have bugs, they will have bugs, and also eventually these become defunct as they stop being pre-releases and they become full releases. And then lastly, they have archived versions, and you can go to this download archive over here, and then you can actually see all of the previous versions. You can go down every single previous version in Unity history. If you want to go all the way back to 2017, they have a whole bunch. They'll tell you if there's like security problems or any real major problems with the engine. But if you were really interested in seeing any of those older versions, you can also go back and download those there. But for the uses of this, or for the case of this workshop, you can download the latest version, Unity 6.3, or I believe the project package that I created was for Unity 6.0, which is 6000.0.49 F1, which should work, which should be fine if you were still using the newest version of Unity. The package should still work well anyway. All right. So moving on from this, creating projects. When you're starting to create your project, you can select templates to start your project with. There's 2D game templates, 3D game templates, etc. You can set your name for the project, location, the editor version. So if I click back up here again, you can see I have all these templates over here. They have 2D platforming templates, FPS templates, VR game templates, 3D mobile game templates, whatever. And really lots of the core templates that you would be using are in the core templates section. They have Universal 2D, Universal 3D, 3D mobile, high def 3D, and then 3D 2D with the built-in render pipeline. The big difference in between the Universal, high def, and then the built-in render pipelines is just the render pipelines for the three different versions. So there are 3 different 3D versions. I would recommend using the Universal 3D pipeline. That one has the most features. But also, if you started, for example, your project with the built-in render pipeline, it's not particularly difficult to transfer over your project from a built-in render pipeline to a universal render pipeline. All right. So you can start off with whatever template you want here. I'll just have the Universal 3D. And then you can click up here to change your editor version. So say you installed a new editor version or you wanted to try an older editor version, you can change which version you were working on over here. And then over here, you can change the project names, change the location of where your project is going to be stored. You can change the Unity organization, which might be empty. Honestly, I've barely ever used the Unity organization. It's not really something you have to work with unless you're working with a big team or a pre-existing game that already has the organization set up. Otherwise, I don't really see a purpose in it. There's Unity Cloud and Unity Version Control, which are both kind of helpful, but also if you wanted to, you could just use GitHub and it kind of negates the effects of using these two. All right. So then here you can press create project, but I actually already have a project created right here. So we'll just keep going to navigating the editor. So this is the default layout of Unity. We have the hierarchy, playtest buttons, viewport settings, the viewport, inspector, and project console. And if I open up my Unity, you'll actually see that my layout is exactly the same. If your layout looks any different, you can go up to the window up here click on Window, and then Layouts, and then click on Default. And it should transform everything to the default Unity layout. All right. Moving forward, we have the hierarchy. So this is a container for game objects in a scene. Here you can add or remove objects in scene view, drag and drop objects to create a parent-child relationship, and toggle the visibility or pickability of objects. So what does all of that mean? Let's start one thing at a time. So in this scene view, you can see everything that's going on in your project or in your game. If we were to, for example, look at this camera, we can see that this camera is also in the hierarchy. If we wanted to see the lighting, we can see the light is also in the hierarchy. Everything that's in the hierarchy is just a categorized list representation of everything that's in the world. All right. And we can add or remove objects in the scene view. So in here, by just clicking up here in this little plus icon and going down to 3D objects or 2D objects or UI or lights, audio, whatever. I'll just add a cube for now. You can just go click on the cube and you can see the cube appears in your scene view. And that's how you add objects, and you can remove them by right click delete, or you could just use the delete key on your keyboard. If you wanted to move around in the scene view the same way that I am right now, you can press and hold your right click, and as you drag your mouse around or your trackpad, if you're on a laptop, you can look around. You actually change where you're looking, kind of like in Roblox, I would say. If you wanted to move where the camera is located, W is to move forward, S moves back, A is left, D is right, and you could press Q to go down and then E to go up. So W, A, S, D, Q, E to travel around. If you wanted to focus on a particular game object, so for example, this camera right here, I can click on the camera and then press F, and then I will go towards or go to a view where I have a good unobstructed view of the camera. All right. And then you could also, for the hierarchy, sorry, coming back to that, you can drag or drop game objects to create parent-child relationships. So if we were to bring back the cube, actually, let's say I had this cube right in front of the camera, and I wanted every time I move this cube, I want the camera to move along with it. What I can do is I can drag the camera onto the cube, which makes this camera a child of the cube. So now every time I move the cube, the camera moves along with it. Sweet. And then there is toggling visibility and pickability of objects. So if I move this cube right here, if I go over, there's a slightly darker part of the hierarchy right here, and I go right next to the cube, you can see a little hand icon and a little eye icon show up right here. So the eye icon toggles the visibility of the cube. So you can see the cube very clearly right now. If I clicked on the eye icon, it disappears because it's no longer visible. And then for the pickability, if I were in this viewport to click on the cube, you can see I select the cube. However, if I disable pickability, the cube is still here. I can try selecting it with all my might, and the cube will not be selected. In order to select it, I'd have to go into the hierarchy, and I'd have to select the cube up here. All right, next up we have some of the playtest buttons. But before we get into the playtest buttons, I should actually, let's get the package imported. So everyone who's taken place in the workshop should have this folder right here, the Unity workshop.unity package. So if you have that already downloaded, you can just drag over here and drop it into your assets folder down here. If you don't have it, it should be in the announcements of the Discord for you to download for the Game Dev Club. So in here you can see all of the things that we're going to be importing from this Unity package. There's art, prefab, scenes, scripts, etc. You go down here to the bottom right, just click import, and you give it a second to import. And then once this is done importing, we're going to need to go into the package manager for Unity. So this all goes through, and then we can come up here to Windows and then package manager. So what's happening in this package manager is in the package manager, there's a whole bunch of features or assets that Unity has or that you have access to that aren't necessarily pre-baked with the engine that everyone gets. So for example, let's say there were specific Unity UI packages that some people would use in their games, but not everyone would use. It wouldn't make sense to force everyone who's using the engine to install these packages. So what Unity does is they put them into this separate package manager where everyone can install them if they wanted to install them and use them. However, it doesn't come pre-baked in the engine to save on storage and to save on performance and everything. So what we're going to do is in the package manager, we're going to go on the left side of the screen here to the Unity registry, and we're going to type in Cinemachine, and we're going to install it here. So what Cinemachine does is it's basically, it's like an extra camera controller on top of the basic camera that Unity already has. So instead of having to program in all the camera logic, you can just install this package and it will do lots of the difficult camera techniques. Like, for example, if I was playing a third-person game and I wanted the camera to move up every time so I don't look through a wall or I'm not looking behind a wall to see the character, if I wanted the camera to move to be like right here, for example, instead of back here behind the wall to see my character over here, the Cinemachine would automatically do that for us. So it's a pretty helpful package. All right, but coming back over to the slide deck, we have our playtest buttons. So the play button is going to start the game in our viewport. The pause button is going to toggle the simulation of our game. And the next frame button is going to advance a single frame if our game is paused. So if I go over into the scenes and then I open up my sandbox over here, you can see a little sandbox project that I have set up. If we press play, the game's going to take a second to load everything up. And once it starts going, you're going to see I have the game playing and it's simulating in the engine. It's not like it launched an extra or a separate instance of the game. The game is being simulated in the engine. If I move around like how I should be. If I fall off this cliff right here into the void and I press pause, the game pauses. I can look around. I can see nothing's moving. The simulation of my game is paused. And then if I were to do the step or advance a single frame, you can see I slowly fall further and further down. And of course, if I were to unpause, I would fall, as quickly as I should be falling. So do not confuse this pause button as an actual functioning pause button for your game. This pause button is just for you as a developer when you're simulating the game. If you wanted a pause button in your game, you'd have to actually program that in yourself. All right. So then we're going to look at the viewport. So the viewport is made of two tabs. We have the scene view and then the game view. In the scene view, you can select, manipulate, and modify game objects that act as scenery, characters, cameras, lights, and more. And then in the game view, you can display how your final game looks. So let's move through the scene view a little bit. We can look through everything. We can explore the entire world. We can go through walls and see what everything looks like in the game. We can select on random objects. We can move them around. We can delete stuff. We can add stuff. This is the developer's view of our game. In the game viewport, however, right here, this is what the players are going to see every time that they play the game. They're not going to be seeing all of this where they get to look around and explore the world. They're only going to see what's happening from this camera. What the game viewport shows is just the perspective of the millions and millions of players who will be playing your game. See. All right. Next up, we have the inspector window. So this window displays all the properties of game objects that you've selected, all their assets and components that they have. And then you can also use the inspector window to view, edit, and add properties or components to selected items. So if I go back over to Unity right here, and I click on this cube, for example, you can see the inspector completely transform. If I deselected the cube, the inspector window would be completely empty. If I selected this door, you have all the components that this door over here has. And if I go back to the box, these are all the components that the box has. So to break it down real quick, you have the transform, which sets the position, rotation, and scale of this game object. Every single object inside your game is going to have a transform. And then you have this mesh filter and then the mesh renderer, which is basically telling the engine what mesh you want to be rendering, and then the actual renderer for the mesh, or the kind of the 3D model representation of the game object. And then you have the box collider right here, which is, it's basically just the hitbox of the object. So if you've ever played CSGO, or if you're a big fighting game person, you know that the actual meshes of the game objects aren't the actual collision boxes. Usually the collision boxes are made up of spheres and cubes and capsules, and they try their best to represent what the game object is supposed to look like. But it's not necessarily the mesh itself. So for example, if I went over to the player right here, you can see the actual collision box for this player is this little bean capsule thing, right? Even though the mesh is this robot guy, the mesh isn't the actual collision. So if something were to hit the robot's arms, it would go straight through them. But the player is most likely not going to be seeing that. They're not going to notice anything like that. All right. Okay. And then we have the project window, which displays all the files related to your project. And it's the main way you can navigate and find assets or other project files in your application. So for example, I can look through everything here. I have all my scripts in this folder. Down in my project window, I have all the different scenes in this folder, and I have all my art in this folder. If you wanted, for example, to bring in, let's say I have this dog animal right here. If I wanted to bring this 3D model into the game, into the scene, instead of going through this plus up here, I can literally just drag and drop the dog right here. All right, and just bring them into the world. I can delete them. We can bring in the horse. We can bring in, I think this is a bison. We can bring in the bison. We can just add them in by dragging and dropping from the bottom down here. Really, all that this project window is it's kind of like a file explorer or a file representation of what is actually in your hard drive. So for example, if I were to right click and then go to show in Explorer over here, you can actually see, let's pay attention. I got art, prefab, scenes, scripts folders. If we go into the actual assets folder for our Unity project, we have art, prefab, scenes, scripts, etc. Right? And then if we go into the art, we can see we have the bison animal, dog animal, horse animal. We have our coin 3D models, etc. If we go into the scripts, these scripts are the same scripts that we're going to see in here. So this is literally just a in-editor version of the File Explorer to let you navigate through your project. All right. After that, we have the console. So the console window displays errors, warnings, and other messages that your editor might generate. These errors and warnings are supposed to help you find issues in your project, such as script compilation errors. So if we go over here into the console, we can see I actually have a warning already. I don't know what that's for. But here is where you can see they will display errors for your game here. They will display regular messages. So for example, if you were writing a script for your game and you missed the semicolon, right? In the console, it would say, hey, there is an error in this script on line X because you missed the semicolon right here, right? Or if you were debugging your game, let's say, for example, every time I pressed the E key, every time I pressed the E key, I wanted to print button pressed, right? You would have a print statement, and that print statement would show up in this console down here. Okay. Moving on, let's actually make a game, or let's work through the little thing that I have set up. I should preface first, I am using the Kenny prototype kit, which is this kit right here. It's a free use. It's not a copyrighted kit or anything, but I really like all the Kennedy assets. I didn't make any of the art for this workshop. I took it from here because I am no artist. But if anyone is working on a game, I'm not sponsored by the way. If anyone is working on a game and they needed, temporary 3D models or 2D pictures or UI, or not even temporary, just 3D models to use, Kenny has a huge list that I know I always use when I am working on my personal game projects. So that's definitely something you should check out if you are interested in using any of those 3D models. All right. But let's move forth into the sandbox. All right. So we have a whole little world over here, and we have this void that we need to get across. We have a button and a door, coins behind the door. What I'm trying to do is get this guy into this little flag area over here. All right. So let's see what we're working with so far. We kind of saw earlier what we have, but let's go through it one more time. We have a guy, a little robot dude. He can run around, WASD. We could try jumping. He's not going to jump because I didn't program that in because I didn't feel like it. All right. And yeah, so we need to find a way to get across this ravine to reach this platform. So what we can do is we can go into the plus up here, 3D objects, and we can make a cube. And we can just name this cube bridge to form a bridge to get our character across this void. All right. So we need to move this cube over here because right now the cube being up here does not help the robot in any way whatsoever. So what we can do is we can click on the cube, and you should have arrows pop up. If you don't have arrows pop up, you can go to this little left tab right here and click on this move tool. Click on the move tool, and then you'll see the arrows pop up. And when you click on the arrows, you can move the cube however you desire. All right. Let's say you wanted the bridge to be a little rotated. Maybe it's angled one direction. You can click down here on this rotate tool and you can angle it however so. And then down here, there's also the scaling tool. So you can increase the width of the bridge and you can increase the length so it actually reaches the other side, right? If you don't want to use the move scaling or rotating tool, you can use the rect tool right here. And what this does is it gives you a little overlay, kind of like a little outer representation skeleton of your cube. And you can literally just drag and morph your bridge however you want, like this. All right. If you don't want to have to go up into this top left corner every single time you want to make changes to an object, you can just press W for the move tool, E for the rotate tool, R for the scaling tool, or T for the rect tool. And it's an instant shortcut to instantly change it to whichever tool you want to be using. Does that make sense? All right, so from here, what we want to do is, well, actually, first up, there is other method to changing the transform of your objects. In case these four weren't enough, you can also click on the transform in your inspector of the object, click on it and expand it, and you can see here you actually have the exact coordinate representation of your transform. So you can see right now this cube is at position -2.3, 0.26, 15.42. Rotation 000, scale 111. What we can do is we can go in, click on the actual text box of the position coordinates, and we can just type in, let's say we want it 000, and you place it at 000. Another thing that you could do is you can click and hold on the letters, so the X, Y, or the Z. If you click on it and you drag left or right, you can see it actually moves the cube this way as well. If you want to make just small adjustments, right? And you don't know the exact number that you want to be moving your cube to. Cool. And that works with the position, that works with the scale, that works with the rotation, that works with all three of the different transform types. Okay. So let's just put the bridge somewhere where it can actually be useful. Let's put it 12.5, scale 10. Right there, and then we can increase the width so the robot doesn't fall off to say 5. Right. I like using nice solid numbers, or perfect half numbers, or 0.25s. There is no reason to do that. I like doing it. I think it's smoother. I think it's cleaner. Now, if we press play and we run over our bridge, we can see the bridge works perfectly fine as it should. Right. All right. Now we need to get through these boxes. And I know that we can just increase the width of the bridge to get around the boxes, but that would beat the point of why I set this up the way that I set this up. So what we're actually going to do is we can go down to these boxes right here, and we need to find a way to enable physics on these boxes to break through them. So instead of just running into them and hitting them like a brick wall, we can actually run into them and run through them like it's a wrestling entrance or something of that sort, right? So in order to do that, we need to click on one. So I'll click on this little one in the middle here, box number 3, and we can go in to the inspector, add component, and we can type in rigid body. So if we type in rigid body, and let me actually move this up a little bit. We typed in rigid body. What this does is this will actually add the physics simulation onto this object. So now you'll see if I run over here and if I hit all the other cubes, nothing happens. But if I hit this exact cube in the middle, you can see it actually moves a little bit. And that's because physics is enabled. Let me move it out so it's a bit more obvious. All right. So I can push it around. Physics is fully enabled on this object. I can push it off. But as we previously saw, there is no physics on any of the other cubes, and that's because we didn't enable it on any of the other cubes. So what we can do is, let's remove this rigid body component right here. We can click on one cube and then hold Control and then click on other cubes. Or if for some reason you didn't want to hold Control, you can click on one cube, hold Shift, and then click on the other cubes. Or if you don't want to do all of that, you can go into the hierarchy, click on one cube, hold Control, and then click on the other ones. Or click on one cube, hold Shift, and then go to the bottom of where you want to select. So box 1 to box 9, hold Shift, and then click on the last box, and then you select all of them. All right. And then if we go here and we add component rigid body and then deselect, now we can see if we click on every single one of these boxes, they will all have the rigid body. So now, if we run through these boxes, we should be able to just push all the boxes aside, like so. Nice. There is a problem though, a problem of preference. I do think it is a little difficult to push these boxes. It kind of looks like the robot's struggling a little bit. So what we can do is we can select all the boxes again. We can change the mass of the boxes. So the mass is, I don't know, I was going to say it's like the weight, but I know that's technically different. If we change the mass to something lighter, like let's say 0.1, and we try running through them again, we're going to see it's actually going to become a lot easier to push through the boxes because their mass isn't as high. I was going to say they don't weigh as much, but that's not true. All right. And now it's a lot easier to push them. There's also linear damping, angular damping, center of mass, etc. Lots of those are just other properties that you can mess with. The biggest one that I can show you with an easy showcaseable feature is probably the use gravity. So if we disable use gravity, that's going to get rid of the negative 9.8 meters squared or whatever it was that physics taught us all that is pushing down on the boxes. So physics will still be enabled on all these boxes, but if I push them, there's no gravity actually pushing them down, which I think is pretty cool. And if we re-enabled gravity, we could see they all just fall back to how they should be. All right. Sweet. So we got through the boxes. We got this little bridge that we created. Now we need to get this little coin right here. But to do that, we need to press this button to open this door. So if we press the button right now, we can see that nothing happens. The button gets pressed and the button stays down, but the door doesn't open up, which doesn't help us with our end goal of getting to this coin. So let's look into how this is actually working. If we come over here and we click on the button, and we can see it has a button script, which I pre-programmed. We can double click on this button script and it should open up VS Code or whichever IDE you have. And while we're here, let's go and click on this door, and we can see it also has a door script. So I could double click that and open that up too. All right, so let's break down what's happening here in the button script. So looking at the button script, it's called button script. We have a private variable, which is of type animator, named anim. So what an animator is it's basically this component right here, or if we go to the button, this component right here. And even for the player, if we go in here, this component right here. So what this does is it basically controls which animation the player is going to be playing, if that makes sense. So this animator is going to be telling the player, or it's going to be telling the door, or it's going to be telling the button, you need to be playing this animation right now. Or, hey, you need to do this animation right now. Or this variable changed, so it's time for you to play this variable. Does that make sense? Is that cool? All right, so that is the animator, and it is named anim in the script. Then we have a method void start. So what void start is this method gets run every single time your game is started. So if we press play right here, void start, the method will run. If your player launches your game, void start, the method runs. All right. So every time the game is started, it sets the variable anim to get component animator. This is a method which basically goes into the game object of where your script is. So since this is the button script, it's this button script, right? It will look through all the components that surround the button script, and it will look for an animator. So it'll go transform, no, mesh filter, no, mesh renderer, no, until it finds the animator. All right. Once it finds the animator, it sets this animator component from this button. It sets that animator component to this variable. So anytime we do something to this variable, we are referencing this animator component. All right. Okay. Next method is the void on collision enter, collision call. So collision call is just the parameters. Basically what on collision enter does is every single time something collides with this game object, the button, every single time something collides with it, this method is called. Okay, so on collision enter and then collision call. What collision call is the name of the collision. The collision is going to be referencing whatever the other collider is that hit it. So for example, if this cube hit the button collider, this box collider would be collision call. Okay, if the player hit it, this capsule collider surrounding the player would be the collision call. Okay. So if we go in here, we can see if call.gameObject.tag is equal to player. What is happening here? There's a lot of dots. So we already know call is this. It's the collider. Or if we come over here, call is this capsule collider. All right. What we're doing is we're getting the game object owner of call. So call.gameObject, we're looking for the owner, the game object owner. So if this capsule collider right here was call, we would look for its game object owner in the hierarchy, which is the player, because that's where the capsule collider is, the component too. Okay. And then we look for the tag. So we're looking for the tag of this game object, which we can see right here. underneath the title where it says the tag. And you can see there's a whole bunch of different tags. Basically, what a tag is it's like a category or like a grouping of a whole bunch of different game objects. And you can put it all under one tag to reference. So you can see we have an untagged tag, respawn tag, camera tag, game controller tag, and we have the player tag. All right. So if we go back into the script, we can see if col.gameObject.tag equals player. So if all of this is equal to the player, so we can look through one more time. We have the capsule.gameObject, which is the player, .tag, and it's equal to player. So when the player comes into contact with the button, this happens. All this is really just playing the animation for the button. There are lots of videos you can look into, lots of resources to look into how the animator works. And also, if you're really interested in seeing how the animator works in real time, in this package, you have all the animator settings all set up. So you can look through it and you can see how the button is working and what this line means in particular. But for the case of this workshop, it basically just means you press the animation or you play the animation to say the button has been pressed. Okay. So that works if the gameObject.tag is equal to player. What would happen, for example, if this cube right here hit the button, right? So we have collision col, which would be the box collider. We go to the game object, box 9, and if we look at the tag, it's untagged. So if any of these boxes over here hit the button would not go down. But if the player hit the button would go down. So let's see if I can showcase that somewhat smoothly over here. So if I push through all these boxes and I try pushing one of these boxes on top of the button, like so, you can see the button does not go down. And that is because the cube doesn't have the tag player. Now, if I were to step on this button, you can see the button does go down. The button is now sunken into the ground, and that is because this game object has the tag player. All right. If I were to put the tag player onto the cube and then make it touch the button would then go down. But I'm not going to do that because it's not a player. Okay. So that's what's happening in the button script. If we go over to the door script, we will see it's for the most part the same thing. We have private animator anim, which is getting the animator variable or declaring the animator variable, void start, and then setting up the animator variable to the animator component that is inside the door right here. And then we have a custom method, public void open door. And then what this does, anim.setTrigger open door, it basically just plays the animation to open the door. All right. So we know what's happening in the door script. We know what's happening in the button script. We need to make it so when the player gets through the boxes, gets over the bridge, and steps on this button, it tells this door right here to open up. And it runs this method right here. So first off, we need to connect this button to this door. And we can do that by making a variable. So if we go into button script, we can make a public variable and we can make it of type door script. And then we could just name it door. All right. What this does is this makes a reference to this script, not the script in particular, but an instance of that script. All right. So now if we let it all compile and we go back to the button, we can now see when we open up the button script, it's no longer just this little script grayed out box. We actually have an input here where we can put in a door script. So we know that this door right here has the door script. If we go to the button, we can drag and drop this door script into here. So now when we look at this door variable in our code, we know that we will be referencing this door right here. Okay? Does that make sense to everyone? Is that okay. So if we didn't want to drag and drop, or let's say our hierarchy was way too big for us to look through everything and we just wanted to see all instances of door script, we can click on this little circle dot right here, and you can actually see every single place that the door script is located. So we have this door, which is door 1, or we have this door, which is door unnumbered, and then this door over here, which is door 1. But for this case, we want to be referencing the unnumbered door. All right. And then now we already have all the code set up to track when the player hits the button. So all we need to do is type in door to reference this door script, which, as we prefaced earlier, was the other door inside the world. Door.openDoor, which is referencing this method right here to play the animation to open the door. Okay. And if we let this compile and we run in, give it un momento, and then if we pressed play now, and we ran over real quick over the bridge through the boxes to hit the button, boom, boom. Now we're going to see when we hit this button, the door will in fact open. Awesome. Does that make sense to everybody? All good. All right. So next thing we want to do is we want to be able to collect this coin right here, right? So if I hit the coin right now, we can see that it just stops me, because really all that this coin is right now is it's basically just a cube. If we go into the game and we click on it, we can see it has basically the exact same component layout that the boxes had earlier, except the only difference is the mesh filter is saying to render in a coin instead of rendering in a cube. All right. So we need to make a script. So in order to do that, we can go here to add component, delete the rigid body, and we can just type in whatever we want to name our script. So let's just call it coin script. And it'll actually say right here, there's no component that exists named coin script. Do you want to just make a new script named coin script? You can just click new script, create and add. Give it a second, and then it'll make the new script for us named coin script. And then we can double click and we can open it and we can see we have coin script. And then in it, we start with the void start, which is something I already showed you. And then there's void update, which is something that I'll go into a bit more detail with later. All right, so we can just delete everything in here. We need to make it so every single time that the player hits this coin, if a player in particular, not a box, hits this coin, the coin disappears, right? So in order to do that, we can just take what we already did with the button over here, void on collision enter if collision.gameObject.tag is the player, to make sure that when there's a collision with the coin and it's the player hitting it, this happens, right? So let's just type that in real quick. So void on collision enter collision col if col.gameObject.tag equals player. Oops. Then whatever happens in here happens, right? So for debugging purposes, just to showcase, to make sure this is working, I'm just going to type in print. So what this method does is it will print whatever I say in these quotation marks into the console, right? So let's just say hit coin. So if the player hits this coin, it will print to us in the console. Let me open up the console. It will print in the console hit coin. So let's run through it real quick and hopefully it works. It'd be pretty bad if it did not. We run over and we could see right there, we hit the coin. All right. And every time that I hit the coin, it prints it again. So really quickly, you can get to the point where your entire console is just made up of a single statement saying hit coin over and over again. And that can be pretty annoying, especially if you have multiple messages that you want to be seeing, right? So what we can do is we can go over here and press collapse. If we press collapse, all the messages that are identical, so for example, saying hit coin a million times, will collapse into a single message. And you can see how many times that message is being called right here, or how many times the message is being printed. So every time I hit the coin, it's still being printed. But instead of printing it and taking up another space down here in the console, it's just adding to this number right here. All right. All right. So we know that we are hitting the coin. We know something happens and this method is working whenever we hit the coin. We need to actually make this coin disappear when the player hits it. In order to do this, we can come over here. We can just delete the print statement, honestly. It's not particularly necessary. And we can put in destroy game object. All right. So what this does, it calls in the method destroy, which will basically delete this game object from the hierarchy, which deletes it from the scene. Okay. But we are in particular, for the parameters, we're putting in game object because that is what we are destroying. We're not destroying this coin script. We're destroying its game object owner, the coin. So now if I press play and I run through again, when I hit this coin, it should disappear. And well, I shouldn't say should. When I hit the coin, it's going to disappear. All right. Awesome. So moving on from that, it would be kind of lame if we were playing Mario or we were playing Sonic and we collected a single ring or a single coin and that was all that was there in the world, right? This coin right now is looking very sad and very isolated by himself. So what we're going to do is we're going to make more coins. So what we can do is we can copy and paste. So Control C, Control V, a whole bunch of coins. But there is a problem with this. Let's say I went to this coin right here and I wanted to change something. I wanted to, I don't know, add a rigid body to it. Why would I do that? I don't know. But I wanted to do it, right? The problem is if I were to click on any of these other coins, like this one, or these two, you'll see the rigid body doesn't show up. It's only on this coin right here. And that's a problem because we'd want all of these coins to be identical to each other. They should interact and they should be exactly the same. So Control Z all the way back to us just having one coin. What we can do is we can turn this coin into a prefab. Now I already have a folder here for prefabs and we could just click, drag and drop the coin into this prefab folder. Prefab folder. So basically what a prefab is it is a game object that is easily editable to, I guess, create itself again multiple times or duplicate itself multiple times. I guess that's the best way I can describe it. So if you were to make changes to this coin object, you can make changes to this prefab. So every single time you place this prefab anywhere, you'd make the changes to all of the placed prefabs. Does that make sense? All right. So let's place a whole bunch of coins everywhere and show this off a little bit. So we have all these other coins. Let's take them out of the ground a little bit. And I want to, once again, try to add my rigid body. I go down to add component. I add my rigid body. And if I select these, there is no rigid body. But the reason why is because if I go up here to overrides, click on this and hit apply all. So now all the changes that I made to this instance of the prefab will happen to all the other prefabs. So now all the other prefabs for the coin should have a rigid body. I obviously do not want a rigid body on my coin, so I can just go to these three dots, remove rigid body, and apply all. And now none of them have rigid bodies. Sweet. So I'm going to run up and collect all these coins, and we're going to see that there is, in fact, a problem with how we set up the current coin collection. Okay, so if we run through right now, pay close attention to the momentum of our character. Every single time we hit one of the coins, and you know what, I'll even do it again. Every single time we hit one of these coins, it completely stops or at least it slows down, the momentum of our player, which is like the opposite of smooth. If you wanted good game feel in your game, you would probably not want it to be like this. Every single time we hit a coin, it stops us and we lose our momentum. That is not amazing. So what we need to do is we need to get rid of the actual collisions that these coins have. And we don't do that by removing the box collider, because we still need to actually see if the player is hitting the coin. What we do is we change this box collider with this little check mark into a trigger. So once we check this, it's still a box collider, but it's a trigger collider. So now if I press play and I run through this coin, you're going to notice it does not slow down my momentum at all. In fact, I run through it and it no longer works either. And that's because it's no longer a collision that's happening. It is a trigger event that is happening. So in order to fix this, we need to go back to the coin script and we need to change this on collision enter. It's really simple, from on collision to on trigger enter. All right. And for this collision, we need to rename it. It's no longer a collision. It is a collider. And once we go back, let it compile. And now when we run into this coin, we're going to collect it properly without affecting our momentum. What is the difference between a collision and a collider? I couldn't really tell you. Oh no. I tried cutting the angle too tightly there. What is the difference between a collision and a collider? I couldn't really tell you. For the most part, in all the ways that I've interacted with them, they are basically the exact same. But you can see if I try hitting the coins now, since we got rid of the on collision, these coins don't work because we never turned these coins into triggers. But if I hit this coin, I'm going to run straight through it and it's going to disappear. Like so. Nice and smooth, very game feel, right? So we need to click on this and override apply all. And now all of these coins are triggers. So now if I ran through them one more time, not one more time, we're going to be running through them a good bit. If I ran through them, you can see I run straight through without any effect to my momentum. Now there's a problem, which is I don't know how many coins we collected, right? I know there's 5 coins. I know I placed 5 coins, but that's because I was counting when I placed them down. The player doesn't know how many coins we collected. And if there were hundreds of coins in this level and they weren't all in this little section, I would not be able to tell you how many coins I've collected. So we need to actually keep track of how many coins we're collecting. We can't do that in the actual coins themselves because every single time we go through one of the coins, we destroy it and we destroy the script. Meaning that if we add the number of coins to the player, or we add how many coins we've collected to this coin script, it would be destroyed every single time we hit it. What we need to do is we can come up to the player right here and we can make another script. Let's call it the player coin script. All right. So we can create this, let it make itself, and then let's open it up. Once again, we can delete all this. And in here, we're going to keep track of how many coins the player has collected. And we're also going to make a method to add to the number of coins that the player has collected. All right. So to keep track of how many coins we've collected, we can just make an int or an integer, right? Which is just a solid number, no decimals, no fractions or anything. Just 1, 2, 3, 4, 5. Because we're not selecting or we're not collecting half of a coin, right? So we can make an integer and we'll just name it coin count. All right. And then actually let's initialize it to 0 because whenever the game starts, you're going to have 0 coins. And then let's make a public method and let's call it add coin. Okay. No parameters needed. Every time we do this, we just do coin count plus plus. And this is equivalent to coin count plus equals 1, which is also equivalent to coin count equals coin count plus 1. Really all we're doing is we're increasing the number of coins that we have by 1. Okay. Then from here, we can print, and let's just say coins, colon, space. And then we can actually add on this variable into the print statement by doing plus, and then just putting in the name of the variable right here. So now in the console, it's going to say coins, and then the number of coins we have. It's not going to say coin count, it's going to say coins 0, coins 1, coins 2, etc. All right. So if we were to let this compile and we were to run through, it would do absolutely nothing. And that is because we are not calling the add coins method anywhere, right? So we can close this door script. If we went over to the coin script, before destroying the coin, we need to actually talk to this player coin script and add a coin, right? So in order to do that, we can kind of combine what we did right here and what we did over here with the get component. So we're combining the col.gameObject and the get component. And I'll break down what that means for you. So first off, we're doing the col.gameObject, right? And if we look over here, what we're doing is we're getting the collision or the collider, and we're finding the game object, right? Now in this game object, we need to get this player coin script. So we can do what we did when we were getting the animator over here, and we can do get component player coin script. So now instead of searching for an animator, it's going to be searching for this player coin script. All right. Now, if you wanted your code to be readable, you would not do what I'm about to do. Now, what I'm about to do is I'm going to put a period right here, and I'm just going to call the method right here, which isn't particularly readable, but it is much quicker. All right. So we'll say add coin right here. So now on trigger enter, before the coin destroys itself, it's going to talk to this player coin script right here in the player, and we're going to add a coin, which will increase the number of coins we have by 1, and it will print that, it will print how much coins we have collected. So now play through it and open up the console down there. If we run through and we select any coins, we're going to see it's going to go coins 1, coins 2, coins 3, coins 4, coins 5. And you can look at it down here. 2, 3, 4, 5. Nice. It is working. We as the developers can now see how many coins we've collected. Only problem with that is the users, the actual players, they're going to see this. Minus this. They're not going to see this part down here. They're just going to see the game. And all they see is that we've walked through the coins and they've disappeared. They still can't tell how many coins we have. And an easy way to show them how many coins we've had is by adding a UI or a heads-up display, a HUD. And we can do that by going to this plus icon in the top left one more time, and then going to the UI section. And over here, you'll see text dash text mesh pro. Click on that. It might ask you to install something. If it does, just install it. It's installing text mesh pro, which is basically the text renderer for the heads-up displays. All right. And we're going to name this coin text. Now, if we go into our game view, we will actually see that the heads-up display has in fact arrived. And we want to put this, instead of putting it in the bottom left, let's put it over in the top right. Okay. And we can type in where we want it to be, 450. We can click on this pause X and drag it around like we did earlier. And we can also go into our scene view, and we can see that this canvas is literally just a representation of what the UI is, right? We can go and click on this coin text and we can move it in here however we so please. Okay. Does that make sense to everyone? All right. All right. So awesome. We should probably change the color so it's not white on a very light background. So we can go down here to the vertex color and we can change it to black. And we can also change the font size. We can change the type of font that we're using. We can change over here the font style. So we can make it bold. We can make it italics. We can underline it. We can strike through it. We can make it all lowercase letters. We can make it all uppercase letters. And we can even all do small caps, right? For right now, I'll just leave it bold and italic. And then let's write here, coins, 0, for how many coins we have. So this is where you're actually going to see the text that is going to be displayed. All right. Little problem. If I were to, let's say, change the size of the screen, we can completely lose the coin's HUD if we change the dimensions of our, or the dimensions of our display, right? And if I were to move this down, we can totally just push it out of the screen. And if I were to move this left side to the right, once again, we could just push it out. And that is because of where the coin's UI is anchored. Right now we can see, if we click on this, the coin UI is anchored in the middle of the screen, at the center of the screen. To better showcase this, I'm going to put the anchor on the bottom left of the screen, which is the exact opposite of where we actually would want it. So what this does is it makes sure that this left side of the coins, it tries its best to stay equidistant from this left side of the screen. So as I move the left side of the screen, the distance in between the beginning of coins and the side of the screen are going to stay about the same. As I move the left side of the screen, the coins text moves with it. And the same with the bottom of the text and the bottom little window here is going to stay about the same, or the distance. And that's not great. So what we're going to do is we're actually going to put it in the top right. And then we're going to set this to be a solid number. Let's make this 50. Let's make this 60. All right. So now if I move the right side of the screen, you're going to see it tries its best to stay the same distance away from the right side of the screen. And if I could move the top of the screen, you would see the same thing. All right. So now we can press play and we can see the UI is in fact up there. But if we were to go and run into the coins and try to collect them, no coins would be collected, which isn't great. So we need to actually go into the player coin script and we're going to change this print to actually change the UI instead of just printing in the console. So to start, we go into the top where it says using Unity engine and we just type in using TMP row or Text Mesh Pro. And the reason we have to add this up here is because Text Mesh Pro is its own separate package. And we need to actually tell Unity that this script has words or keywords or phrases and logic that requires you to use this package. Okay. So using TM Pro, let's just make another public variable and we're going to say TMP underscore text and we'll name it coin text. Okay. So TMP underscore text is the, if we go over here, it is this actual UI Text Mesh Pro text right here. This is what we're referencing for the variable TMP underscore text. Okay. Now what we're going to do is we're going to delete print right here. And we're going to type in coin text dot text equals this. Oh, it's not that, this. So we are setting the text of this text box right here. So we're basically going from here, we're selecting this text and we're going to set this equal to coins colon plus coin count. All right. So we press play. We walk through. Now, if we click this button and we collect these coins, we're going to see the UI actually changes to say, oh, that is a problem. One little thing that I missed. The script right now does not know which coin text it is referencing. If we go into the player coin script, there is no reference to a TMP underscore text. What we need to do is actually go down here, drag and drop it in. Okay. So now if we were to press play and we were to run through all the coins, now it should display how many coins we have. Like so. Awesome. Does that part make sense to everybody? Everyone all good on that? All right. So we've collected coins. We've pushed this button to open the door. We've gone over the bridge. We've gone through these boxes. Now we just want to pull this lever, open this door to get to this flag so we can make it to the next scene. Problem is, I don't think this lever works. If I were to run over and I can try pressing E, I can try pressing F, whatever your preferred interaction key is, it does not work. And that's because I haven't coded any of it yet. So what we need to do is let's check out what we have so far. We have one box collider, which is not a trigger, which we can see is this box right here, which basically acts as a collision box for the lever, so the player can't just walk straight through it. We have a trigger collider, which I'm assuming is this outer one right here. Yes. Very nice. Which I'm assuming is to tell the engine the player is in range or the player is not in range. We have an animator and we have this lever script. So if I double click on this, we can see that it's already referencing this door right here, door 1. So we already know that the door and the lever are connected. And if we look through the script, we can see door script. We already have a Boolean variable or a bool called player in range, and it's set to false. So a Boolean can be true or false if you did not know. And right now it's false because the player does not start the game in ranged. We have a Boolean called flipped, which is if the lever is flipped or not, and then private animator anim like earlier. Our void start is exactly the same as the door and the button. It just gets the animation component. We have this void update, and then we have a custom method called flip lever. So if the lever is not flipped, then the door opens, and then it anim set bool flipped equals true. And something that I'm just realizing that I didn't have over here is it needs to set flipped to true. All right. Not really necessary, but it's definitely nice. So what we want to do is we want to make it so if the player is in range and presses, we're going to say the E key, because that is my preferred interaction key, then this method is called to flip the lever. So first off, we need to do if, and then let's check to make sure the player is pressing the E key. Input dot, or, I missed something. I didn't explain what method this is. This is the void update method. So what this method does is it runs every single frame that is rendered. All right. So if I pressed, or if I typed in here, print frames, right? And I let this compile, we should be getting 60 frames in the console per second. Hopefully, if my computer is working as it should be. So let's press play, and I'm actually going to uncollapse this so we can see just how quickly it moves. Once we let this let it do whatever it's doing. All right, there we go. So if we press play, we're going to see this console is going to absolutely blow up with frames. And there we go. Instantly, it's already completely filled. If we collapse this, we can see it's going up a bunch every single second. That's because it's happening. This method, print frames, is happening, or this line, print frames, in this method is happening every single frame. Which I would hope is actually more than 60 frames, but I guess I don't know how I would calculate it. So we know void update happens every single frame. So what we need to do is we need to check to see if the player is pushing a button, and we need to be checking that every single frame. So what we're going to do is we're going to do if input dot get key down, and then we're going to type in here E. Oops. And then we could just print here to test to see if the button is being pressed. Button is pressed. Okay. So what input.getKeyDown is it checks to see if you are pressing a key, if the key goes down. And it only happens a single frame when the key is first pressed. There are two other forms, and I can actually just copy and paste this. There is getKeyUp, which is the button being released. And then there is getKey, which is just if the button is being held. All right, so to showcase this a little bit here, let's press play and start it. If I press the E key, we're going to see button is pressed and button is held. And if I release it, button is released will pop up. And you can see whenever I press the button, it happens one time right there. And every time that I'm holding the button, it is being printed every single frame that I'm holding the button. And when I release the button, it prints itself one time. Okay, so that is button or key down, key up, and key. Does that make sense to everybody? Awesome. So now what we're going to do is we can remove the print statement. We're actually going to just flip the lever here because I foresee absolutely no problems with putting that method right there. Okay. And if I press play and I run over here and I accidentally press the E key, oh no, the door opened when I pressed the E key. I guess it's a good thing that the lever was flipped and that the door opened and that that method works when I coded it to work, but I was able to open it all the way over here. And that's because I'm not checking to see if the player is in range or not. So what I can do is I can go to this if and I can just type and player in range. So now if the E key is pressed and the player is in range, the lever will be flipped. But that of course leaves us with the problem that the player in range variable is never being changed. So it's always false. So what we need to do is what we did with the coin script, and we need to do void on, oh, not con, on trigger enter, collider col, and then if col dot game object dot tag is player, then the player is in the range. Oops. Does that make sense? The problem is if the player enters within range and then leaves, the player in range variable will always be true because we're never resetting it to be false. So we can just copy this. And instead of on trigger enter, on trigger exit, and player in range can be set to false. All right. So now if we come back over here and we run all the way over to the lever, we should be done with this little sandbox scene. I can spam E, lever does not open. I can come into this area and leave the area, spam E, lever still doesn't open. I can go right next to the lever and press E, and the door opens and the lever flips very nicely. Press the button, collect the coins, run out again, and I can go over to the flag and nothing happens because I didn't program anything to happen. All right. Does this whole workshop area make sense to everybody? Everything all right with this? Any questions about anything that's happened from the lever to the button to the coins to the heads-up display to the rigid bodies on the cubes to the bridge, anything? whatsoever. All right, so I do have one more sandbox area for us to run through. And we're going to say whatever. And we're going to see a big problem with the sandbox area. And that is that it is pitch black. I'm opened the dark sandbox, if you're following. It is pitch black. You cannot see a single thing except for the sky, which is not great. And it's because there is no lighting in here. So if over here in the viewport settings, what we can do is we can turn on wireframe draw mode, right? And we could see all the wireframes, which is just the triangles and the polygons for the rendering of your scene, right? Which is cool looking. It looks like Tron. We can turn on the shaded wireframe draw mode, which looks the same as the shaded mode right here. And that's because the wireframes are black and everything is so dark that everything is just black. So we can't really see anything anyway. And we can turn on right here, which is what would actually be useful, the unlit draw mode right there. And we can see this is what the game looks like with absolutely no lighting. All right. But there is still a problem of if we go into our game view, it's pitch black. How do we fix that? What we can do is we can add lights. That might be a bit of a revelation. So if we go into the plus over here, there is a whole little light section. Now, I'm really going to showcase the directional light, point light, and spotlight. But there's also the area light, and there's a whole bunch of other things with reflections and all these different volumes and such. But I would say these three are the big hitters. Okay. Now let's go into the shaded mode so we can actually see what happens when we put on the lights. Go into plus, lights, add the directional light, and everything lights up. It's so cool because really what the directional light is it's like an overarching general, basically it's like sunlight. Sunlight is kind of just always there and it always just lights everything up. And that's essentially what directional light aims to mimic. You can even rotate the directional light and you can change the direction that the light is coming from. There's no shadows right now, so you can't really easily showcase this, but I can just add shadows in real quick. And now you can see as I rotate this directional light, I'm actually moving the shadows because we're kind of just changing where the sun is coming from, right? Pretty cool. But I think that makes things a little bit too easy. So I'm actually going to delete those. And that leaves us with the point light and the spotlight. And I could just add these both, honestly, right on top of each other. And let's just move them slightly away. And here is the easiest comparison that I have for both of these lights. A point light is like a hanging light bulb. It kind of just lights up everything around it in its general area, right? A spotlight is a spotlight, like in a Broadway show, or like when you're singing on a stage for opera or something like that, right? Spotlight, pretty self-explanatory. You can change the intense areas of the spotlight. So right here, you can change the inner angle of the light and the outer angle of the light. You can change the color of the light right here. So you can make it red, you can make it green, you can make it whatever. You can also change it to a temperature kind of thing. All right, so if this was white, it should just turn orange to make it a warmer color and blue to make it a lighter color, like it's winter or something. I usually just leave it on color. All right, let's make it green. We can change the intensity of the light, how bright it's shining. We can change the indirect multiplier, which really only works for, as it says here, directional lights. And then there is the range right here, which expands the range of how far the spotlight reaches. So let's increase the range a little bit here. And you can see, you can make it pretty wide. All right. But we're not going to use the spotlight either. We're going to use the point light. So we have the point light, which is the same thing. We can change the color. Let's make it orange. Change the intensity, indirect multiplier, range, everything basically exactly the same as the spotlight. All right. And now if we press play and we run around the world, we can see that the light is in fact shining up the world. But if we leave, even just slightly close to the light, it becomes pitch black very quickly and we don't know where we're at. And then all of a sudden we are lost. So let's just have the light follow the player. So we could code that in, or we can just do what I showed earlier with the parent child and just attach the point light on top of the character. And we could just put this at 0. Let's put it at 3 and then 0, right? And now when we press play, we're going to see the light actually follows us. But the problem is now it doesn't even look like we're moving. It kind of just looks like we're playing the animation in the middle of the screen and nothing is really happening. So if I were to click on this scene view right here, and let's just drag it over to where the inspector is. By the way, you can do this with every single window. If I wanted the hierarchy to be over here, I can put it right here. Although it's kind of weird to put it right there. If I wanted the project or the console to be up here, I can move those up there. If I want the scene to be right here, I can move the scene right here. All right. And now if you were to move around in the game, you can see the character is actually moving. It just doesn't look like it on the screen because the light is attached to them. Does that make sense to everybody? All right. All right. Last part is it does not make sense where this light is coming from in the slightest. It doesn't make sense why there's an orange glow around the robot because nothing is showcasing that there could be an orange glow. So what do? We can change the material of the robot to make it glow, to make it look like he is shining, to make it look like maybe the light is coming from the top of the robot's head or something, right? So I'm going to go back into the unlit draw mode and we're going to make a material for the head of this robot. So we can go down into our project and then right click, create material. All right. And then let's just name it head map. Now, if we were to drag and drop this material, we can drag it anywhere. It's called head meta, so I'm going to put it on the head of the robot. Now we have this whole material that can completely change what the robot looks like. If we wanted to change the color of the material, we can make it black, we can make it red, we can make it purple. And down here, it's actually a little difficult to see because of my keystrokes. You can see down here, there is a preview on a sphere of what the material would look like if it was on a sphere. And as we increase the metallic map, you can actually see the changes that we're doing in real time on this preview. So as we increase the metallic map, we're actually going to see it makes it look a lot more like a brand new, like, I don't know, like a shining car or something. Makes it more metallic, like it's Iron Man's armor, right? And then for the smoothness, we can decrease the smoothness until it's so flat that it looks like a bouncy ball. It's devoid of any light bouncing off of it whatsoever. Or we can increase it so high that it looks like we just pulled it out of a river and it's dripping wet. All right. Or we could just leave it in the middle like normal. And then there's a couple other things. There's a normal map, height map, and occlusion map. I don't think I really have time to go into detail with what all three of these are right now. But basically what these are they kind of mess with how the material is rendered to make it look like there is geometry, or to change how the shading of the material is rendered in the game. All right. But those are definitely very important things to know to make your game look beautiful. AAA developers all over use normal height maps and occlusion maps. So I would definitely look into those, especially once you're nearing, I guess, the polishing or even just the making your game look pretty phase. All right. And then we're going to add right here emission. And what emission is we will basically make it light up with the emission. And if we go back into shaded draw mode, we're going to see, we can kind of tell that it's a different color, right? We can kind of tell that the head is a different color, but not really. And it doesn't even look like it's lighting anything up because it's not. So if we turn on emission and we turn it from black to, let's make it white, we can see now that the head in the game view and in the scene view is actually glowing. If I turned it off, you can see nothing. Turn it on, it's glowing. Pretty cool. And we can change the color of it. So we can make it so it glows pink. We can make it so it glows blue. We can make it so it glows orange. So it kind of actually makes sense, right? And then we can increase and decrease the intensity of the glowing, like so. And just like that, now when we run around this little dark sandbox area, it almost makes sense why there's a light surrounding the character. And I think with that, if I close everything, that should be it. Awesome. So if you are interested in joining the Game Development Club on Steam, here's a little QR code to do that. If you're interested in following the Game Dev Club on Instagram, here's another QR code to do that. And if you're interested in checking out the DHC, which I am once again a student fellow for, you can check it out here. All right. I hope everyone who attended learned a little bit of something. I hope everyone who's watching on the internet in the future can learn a thing or two about using Unity and can learn the way around it. Good luck to all the teams this semester with all of their projects. Good luck on all of your semester-long MVPs. Thank you, Dachi, for letting me host the Unity workshop for this semester. Hope everyone was able to learn a thing or two. Thank you so much, and I hope everyone has a good weekend and good semester.